This is a lecture for section 10B, problem solving with geometry. We can locate any place on the Earth's surface by its latitude, which is the north and south measurement from the equator, and its longitude, the east and west position from the prime meridian. So you can see on some examples here, Rome has a latitude of 42 degrees north and a longitude of 12 degrees east. Miami is 26 degrees north and 80 degrees west. Let's look at some questions here. Question A, suppose you could drill from Miami, which is a latitude of 26 degrees north and a longitude 80 degrees west, straight through the center of the Earth and continue in a straight line to the other side of the Earth. At what latitude and longitude would you emerge? Question B, perhaps you've heard that if you dug a straight hole from the United States through the center of the Earth, you'd come out at China. Is this true? Suppose you travel 1 degree of latitude north or south. How far have you actually traveled if the circumference of the Earth is about 25,000 miles? First question was Miami, which was 26 degrees north and 80 degrees west. What is exactly opposite of it on the Earth? Well, the first thing you're going to do is the exact opposite latitude. So rather than being 26 north, we're going to go to 26 south. So our answer is going to be 26 degrees south. So the north and south degrees just flip-flop. For the longitude, what we're going to have to do is they have to be 180 degrees away. So you're going to work on that prime meridian. You're at 80 degrees west, and then you have to move 180 degrees either east or west and figure out where you're going to end up. So if you do that, you go 80 degrees east. That's going to get you to the prime meridian. So if I'm at the prime meridian, and I'm over here at 80 degrees west. If I go 80 degrees this way, it's going to get me here. And then I need to travel another 100 degrees. I'm going to end up on the east side for a total of 180 degrees. So then the longitude is going to be 100 degrees east. And if you looked at that point would be in the Indian Ocean. The second question asked, if we were to drill a hole straight through the United States, through the center of the Earth, would we come out in China? Well, we know the United States is in the northern hemisphere. So if we are going to go through the Earth completely, the north value is going to turn into a south value. And China is in the northern hemisphere. So there's no way that we could go through the Earth and end up in China, because if we're going to the center of the Earth, we have to go from north through the center. We're going to end up in the south. The last question then leads to what we did last section with the degree measures of a circle. We know that our entire distance around the Earth is 25,000 miles, and that 25,000 miles is representative of the entire 360 degrees. So if I take 25,000 miles and divide by 360 degrees, it's going to tell me how much I would move every degree along the Earth. So 25,000 divided by 360 is 69.4 miles. So roughly 69 or 70 miles that I'm going to travel if I want to move just 1 degree of latitude north or south, or 1 degree of longitude east and west. Pitch, grade, and slope are some other concepts we will see in the world. Consider a road that rises uniformly 2 feet in the vertical direction for every 20 feet in the horizontal direction. We would say that the road has a pitch of 2 in 20, or simplified 1 in 10. Meaning we are going to go up 1 foot for every 10 feet that we move over. So that's kind of like the slope. So pitch is going to be 1 in 10. So you'll have that word in. Slope is going to be the fraction 1/10. So thinking up 1 and then going over 10. And then the last one is the grade. The grading is the percentage. So if you do 1 divided by 10, you get 0.1, which is 10%. So all three of these talk about the same thing as far as the steepness of something, and they are still different in how they are written. Now are some questions for how steep is it? First one, suppose a road has a 100% grade. What is its slope? What is its pitch? And what angle does it make with the horizontal? Question B, which is steeper, a road with an 8% grade or a road with a pitch of 1 in 9? C, which is steeper, a roof with a pitch of 2 in 12 or a roof with a pitch of 3 in 15? The answers will be discussed on the next slide. The first one was a 100% grade. What does that mean? Well, 100% means we got the decimal of 1. So if I'm going to put 1 into a fraction form, that's 1 over 1. So 1 over 1 is going to be a perfect, go from 0, 0 to 1 over 1 to 2 over 2. And if you think about the x and y axes as a perfect 90 degree, if I'm going to go up the exact middle diagonal here, I'm going to make a 45-degree angle, which is half of the 90. The second question asks us to compare a pitch of 1 in 9 with an 8% grade. So 1 in 9, I first have to change that into decimal form. So 1 out of 9 is 0.11. 0.11 means 11%. Clearly, 11% is steeper than 8%. And then we'll do the same with the roof. 2 in 12 has a slope of 2 over 12, which turns into the decimal 0.167, or roughly 16.7%. 3 in 15, if I change it to a fraction of 3 over 15, is 0.20, or 20%. This value is larger, so it is also steeper. Another common formula used in geometry is called the Pythagorean theorem. Now, Pythagorean theorem only works if you have a right triangle. So you must have a 90-degree angle in your triangle. It cannot be used for any other triangles that we see. If you have a right triangle and you have the sides A, B, and the hypotenuse is C, the C is always the hypotenuse. Then you can find C by doing A squared plus B squared equals C squared. Or you could find any of the other sides possible. Let's say we have this property given to us in this picture on the right-hand side. We want to find the area of this property. Well, this is a triangle, and in order to find area of the triangle, we need the base and the height that are formed by the 90-degree angle. So right now, I'm currently missing this side. So the first thing I have to do is start with the Pythagorean theorem. And we know that a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Now, the problem is that we are missing b, or the height. So what we can do is we can rearrange this formula by moving some things around. So if a squared plus b squared equals c squared, we can move a squared to the other side by subtracting. B squared equals c squared minus a squared. And then to get b, just b, to undo a squared, we square root both sides. So b is the square root of c squared minus a squared, which is exactly what we have down here. Filling in those values now, C was 1,200 feet, and the base was 250. So I would go to a calculator and I would type this whole thing in, the square root of 1,200 squared minus 250 squared, and I would get 1,174. So this now is my height. This is my base. And once I have my base and my height, I can find the area of this triangle. Well, area is 1/2 base times height. So if I do 1/2 times 250 times 1,174, I'm going to get 146,750 square feet. Now, the last part of this question asked us to change it into acreage. And what you need to do in order to do that is know that 1 acre is every 43,560 square feet. So if I have 146,750 feet, all I have to do is divide by this value here, 146,750 divided by 43,560. That is about 3.4 acres. Another concept you may remember from geometry is talking about similar triangles. Two triangles are similar. First off, all of their angles must be paired to be the same. So this angle A, if it is 42 degrees, this angle A over here has to be 42 degrees. And if B is, let's say, 65, this one must also be 65. If two of the angles are congruent to two of the angles over here, then the third angles must also be congruent. Then the second part of this is that all the sides are proportional. So what that means is something like this. If the sides over here were 3, 4, and 5, the sides over here could be 6, 8, and 10. They're proportional. 3 to 6 is exactly double. 5 to 10 is exactly double. And 4 to 8 is exactly double. So the relationship between all the pairs of sides is going to be the same. This slide puts in words exactly what I drew on the previous slide. Corresponding pairs of angles are equal. So A and angle A prime are congruent, B and B prime, C and C prime. And then if I make ratios between the matching pairs, then A with A prime, B with B prime, C with C prime, all of those ratios are going to have to be equal. This problem wants us to find two missing sides, A and C prime. They're telling us that the two triangles are similar, and we can use the facts of what we know about similar triangles to solve for the missing sides. What that means is A over A prime has to equal B over B prime has to equal C over C prime. So what they did is they paired all of them together. So A over 4, 9 over 6, and 12 over C prime. So just pairing all of the pairs together. And then what you can do is you only need two fractions to be able to do the problem. So the first problem is going to take A over 4 and 9 over 6. What I do in this situation, and when I have two fractions equal to each other, I'm going to cross multiply. So my first step is going to be 6 times A equals 4 times 9. 4 times 9 is 36. And then to get A by itself, I need to divide, and that's how I get A equals 6. For the second problem, I'm going to go back to that same 9 over 6. That's the paired relationship that I have. And now I'm going to go to the other fraction with the letter that I'm missing. So 9 over 6, so I'll use 9 over 6 equals 12 over C prime. I'm going to cross multiply. So 9 C prime equals 6 times 12, that's 72. And then if I divide by 9, C prime is equal to 8. And you can see here that they actually did they have a typo here. This should be a 6, not a 4. But they got our same answer of 8. So A over here is 6. And C over here is 8. This is the final problem of the semester. You have 132 meters of fence to enclose a corral. What shape would you choose if you want to have the greatest possible area? And then what is the area of this corral? So what they do is they pick two shapes here, a square and a circle. If we have a square, we need to think about the fact that the distance around the outside is 132. So the distance around the outside, I don't know this what each side is, but there are 4 sides of a square that must be equal. So if I take 132 divided by 4, I get 33 per side. So 33 here, 33 here, 33 here, and 33 over here. And then they show how you get the area. Well, area is side squared. So 33 times 33 is 1,089 square meters if I did the square. Now, working with the circle, the distance around the outside of the circle is 132 meters, and that is called the circumference. So the 132 is equal to 2 pi r. Before I can figure out the area, I need to know r. So to get r by itself, I need to divide by 2, and I also need to divide by pi. When I do that, I get about 21. Is about what I got in my calculator. So it's going to be a little slightly off from the answer they have here, but that's okay. Then they take this value and can then do area of the circle. So area is pi r squared, and I'm going to plug in 21. So 3.14 times 21 squared. And I got 1,385. So because I rounded back here, my answer is a little different than what they have in the book version. But this one is larger than the other one. So the circle is going to provide the greatest area for our corral. This is the end of this week's section. It is also the end of notes for this semester. You have to complete 10A and 10B Pearson homework. You will also have to complete your discussion board. Then next week is your final test. And after that, you are done with everything for this class. I hope you had a great class, and I wish you the best of luck in your future.